This is problem number 4 on the practice problems for quest number 4. Factor each expression completely. If it is not factorable, state that it is prime. Note that these are not equations and cannot be solved. Part A, 4x squared minus 100. So again, we're not going to introduce an equals 0. We're not going to try to solve for x. There's no equation in this one. We're just trying to factor. So first thing you do for just about any factoring problem is see if you can factor out any kind of GCF. So what's the greatest common factor for both of these terms? It's 4. So we get 4 coming outside, x squared minus 25 inside. And then x squared minus 25 hopefully looks familiar to us. This is a difference of 2 squares, x minus 5x plus 5. I've made a mistake here. Really easy to forget to put the GCF out in front. It does not disappear. This is our answer here. Part B, 36b to the 7th minus 54b to the 6th plus 20b to the 5th. All right, this one's going to take some space, so I'm going to start it up here. I'll put a line. Okay, again, first thing to look for is factor out the GCF. So what number goes into 36, 54, and 20? I think 2 is the best we can do. And what's the most b's you can take out? You have b to the 7, b to the 6th, b to the 5th. You're going to take out the smallest amount of b's you see, which is b to the 5th. So pause the video here and then come back when you factored it out and filled in the parentheses. So I got 18b squared minus 27b plus 10. And this is still pretty rough to factor. You got different options here. You can use the trial and error method. Ultimately, this is supposed to equal, and I'll put the long-term goal, ultimately supposed to look something like this. The question is what goes in those 2 parentheses. So you can do trial and error. I'm a little bit scared by the 18 and the 10. They have a lot of factors. You can do the box or rectangle method from your book. I prefer funky factoring. I'm just going to go through the highlights here. I won't do the whole thing. But for funky factoring, you take the 18 and get it out of the way. So we'll jam it in with the 10 by multiplying. Still not easy because we're looking now for numbers whose product is 180 and whose sum is negative 27. So I'm not going to list all the factors here, but for example, you're going to want to make a table. And for example, product of 180 could be like 2 and 90, could be 3 and 60. I'm going to skip some, 10 and 18. There's a long list. So again, pause the video, see if you can find somebody in this list that adds up to the right thing. The right thing is negative 27. I guess that means we probably should have put negatives in front of all of these guys. So pause the video, come back if you think you found it. So if you came up with 12 and 15 or negative 12 and negative 15, then you did it right. So let's come back over here then and say this guy is equal to, we got b in front of both. We found out negative 12 and negative 15 were the winners. So that's from here. Okay, but this is funky factoring, so we have to pay for the fact that we moved the 18 from the beginning out of the way. So I'm going to copy everything here. But notice I'm leaving a little gap in the front of each of the b's because that's where the 18 is going to return to. So we've got all this, and then we'll bring the 18 back. 18 comes in front of both. And then we divide each piece by the greatest common factor. So we're going to divide both parts of the first piece by 6, both parts of the second piece by 3. And let's write down what we're left with. I'm going to steal some space from this other question. So what we're left with, 6 into 18 gives me 3, copy the B. 6 into 12 is a 2, copy the minus sign. And then on the other one, 3 into 18 is 6, copy the B. 3 into 15 is 5. So we get 3B minus 2 times 6B minus 5. We're going to put those back into the original parentheses here. 3B minus 2, 6B minus 5. And it might be tempting at this point to start using our zero product property and try to solve, 3B minus 2 is 0 and 6B minus 5 is 0, but there's no equals 0 anywhere on this page. So I know maybe folks end up getting trained. They feel like anytime they see something like this, they start using the zero product property. Not on this page. There's no equations, so we're done. I'll highlight it in red. Here's our final answer. Moving on to part C, 9a squared b squared plus 9ab minus 4. Nothing easy here. Again, it looks like a funky factoring thing to me, so I'll take that 9 and move it out of the way. If you prefer the box method, go for it, but I'm going to illustrate the funky factoring again. So a squared b squared plus 9ab minus, and then the 9 gets shoved over here and multiplied by the 4, so we get minus 36. Okay, now we're ready for our product sum business, P and S in that order. Product is negative 36, sum is positive 9. So at least these numbers are a little more manageable. Pause the video, see if you can find the two numbers that we're after. Okay, so if you're back, hopefully you came up with some combination of 12 and 3. Just have to make sure we put the signs in the right spots. So the 12 there, 3 there. Looks like we need a positive in front of the 12 and a negative in front of the 3. Positive 12 and negative 3. What goes in the front? Well, normally it's x and x. In this case, it's AB and AB. That's how we're going to get a squared b squared in the front. Okay, so it's funky factoring, which means it's not done yet. So I'm going to copy all this, leaving a little bit of space in front of the each term in the beginning. So AB with some space in the front. And in that space, we're going to fill in the number that was there the whole time, which was this 9. So the 9 comes in, and then we divide each term separately, each parenthesis separately by the GCF. So both of these guys are divisible by 3. Both of these guys are also divisible by 3. So when all is said and done, we end up with 3 goes into 9 3 times, copy AB. 3 into 12 is 4. 3 goes into 9 3 times, copy the AB. 3 into 3 is 1, copy that negative sign. And I think we're done here. Okay, moving on to part D. So let's start drawing some more lines to separate these problems. Okay, so part D. Again, first thing to do is pull out the GCF. It's always the first thing we look for when factoring. So what number goes into both is a 9. How many x's can you take out of both? 3. So pause the video and fill in the parentheses. And we should get x to the 4th minus 9. Now that x to the 4th minus 9, I'm hoping, rings a bell, because it is a difference of 2 squares. So we all know the plus 3 and the minus 3, but the x to the 4th is a little different than what we're used to. So how can you put two things here and here that are exactly the same that multiply to x to the 4th? So in this case, they both need to be x squared. And it might seem like we need to go even further. X squared minus 3 looks like another difference of squares, except 3 isn't a perfect square. So we can stop right there. Don't forget to leave that 9x cubed in the front. Greatest common factors don't disappear. Finally, 9x squared plus 16. Easiest problem on the page. Also very easy to make a mistake on this problem. it is tempting to maybe try to do a difference of squares thing here, 3x, 3x, 4, 4, maybe a plus, maybe a minus. But that's not going to give me a positive 16, maybe a plus and a plus. That's not going to work either because the outers and inners will show up. I don't have any just plain x terms sitting in the middle of this thing. So how do we factor this? We don't. There's no formula for the sum of two squares. This one is prime or cannot be factored.